Dodge unleashed a monster of a car at this year's New York Auto Show, packing 840 horsepower into a street-legal vehicle. On this week's show, we've got the story behind the Dodge Demon.
In the auto industry, you need a partner that can develop the next game-changing technology and mass-produce it quickly. BorgWarner can. Our expertise drives future mobility trends with fast-to-market solutions for clean, efficient propulsion systems. We understand the challenges you face. We know what you need to get ahead. We take innovation from the drawing board to the road quickly, providing localized production around the world. BorgWarner, your partner in propulsion system solutions for a cleaner, more energy-efficient world.
And now, here's your host, John McElroy.
I want to thank you all for joining us on Autoline this week. You know, in the automotive industry, there's been so much focus on electrification and hybrids and even fuel cell cars. But the piston engine's far from dead, and in fact, one of the fastest growing segments in the business right now is with performance cars. And we're going to talk about one of them today because it's a demon of a car, a Dodge demon of a car. And joining us as our special guest is Chris Cowlin. He's the Director of Advanced and SRT Powertrain Engineering at Fiat Chrysler Automobiles. Chris, great to have you on the show today.
Pleased to be here.
Also joining us are Elisa Priddle with Motor Trend and Gary Vasilash with Automotive Design and Production. And great having the both of you two here.
Thanks, John.
Thank you.
Chris, let's talk about your car. And I'm curious why the company even decided to go ahead with it. 2 years ago, Fiat Chrysler came out with the Hellcat. 707 horsepower V8, unbelievable performance, and now you've come out with a car to top even that. What's the thinking behind coming out with a car like the Dodge Demon?
Well, we thought we already had the ultimate track car in the Viper ACR, so you know, the fastest car around a road course, and really wanted to look at the growing sort of area of drag racing. How could we produce a street legal car that the guy could take to the drag strip and do a quarter mile in 10 seconds? So it was a really, really simple target. Obviously a lot of engineering goes into it, but that was basically what was behind it.
Is it just a Hellcat with a bit more boost to it, or what did you have to do to get this car to perform?
Obviously an awful lot of changes to make the difference in performance. We've got to produce a huge amount of power, a huge amount of torque, but we've also got to get the car to hook up. So a lot of changes just on the powertrain side. On the engine, about 62% of the parts in the Demon engine are different to those in the Hellcat engine. So no, it wasn't just turning the boost up. There are a lot of changes.
So you've gone to 840 horsepower with this engine. So, I mean, the pressures in the heat have to be enormous. How do you manage those things?
Yeah, I'll give you a couple of crazy numbers actually. 135 bar firing pressure in each cylinder. That results in about 11 tons of load on top of each piston, and that's happening 50 times a second. So you can imagine being able to react those loads throughout the structure. That's one of the biggest challenges that we have. How do we handle all of that heat, all of that mechanical loading in a structure with an engine that passes full durability? We give a warranty for, and we expect to be used and abused on a drag strip. So they're the biggest challenges we have in creating a product like this, and it's emissions legal. It's very, very easy to take an engine, and if you ignore all the emission requirements, ignore the temperature limitations for after treatment systems, you know, you can produce a lot more power than we do from the factory. But this had to be fully street legal, so we've got to respect all of those limits, cat temp limits, and basically engineer a car that after 150,000 miles will still pass emissions. That's the main challenge.
But you actually, I mean, you have huge vents and scoops, and you have a special cooling system.
Sure.
You're not doing
Absolutely, yeah. A couple of the key parts. It's all about airflow. We've got to get air into the engine. We get air into the engine, we can get fuel into the engine. So it starts really with the induction system, the huge scoop on the hood, and the induction system that we engineered drops the induction restriction from a Hellcat to a Demon by about 35%. So the engine breathes much easier. Then we put a much larger supercharger on, 2.7 litres instead of 2.38 litres. Then we drive the engine faster. Instead of 6,000 RPM rated speed, we drive it to 6,300 RPM. And then we've got the chiller system, which basically uses the air conditioning system to do double duty and drops those charge temps, so we don't have any knock problems. We can put more spark in the engine, get more power.
And then I think there's another feature too for people. Once you've run some hot laps, you can sit there and use the screen to monitor how quickly cool down to be able to go again. Yeah,
we show that you can actually monitor the air induction temperature through the chiller. So the chiller runs after the lap, and basically you can monitor that temperature dropping, so you know you're at the ideal temperature to go and run again.
Chris, go back to that air conditioner that you're using, because I think this is unique in the business. I've never heard that. If I got this right, you've got the regular air conditioner in the car, but when you really want to go and do a drag run, you use the air conditioning to cool the air going down into the engine for more power?
Absolutely. We use the capability that's engineered into a normal air conditioning system and then divert that heat rejection capability into the coolant system, which is the low temp coolant system that we use to reduce the charge temperature. So, and it's interesting actually, that came from my advanced group, not the SRT group. The idea came from the advanced engineering group because we think it may be a technology that could work in the future for the ultimate efficiency in other types of IC engine where we're not just chasing power.
So for people who are not into drag racing, and you keep talking about chilled air, aren't engines meant to be hot so they'll combust, not cool, so they'll go fast? I mean, explain that to what the chilled air does.
The chilled air, basically, the colder we can make the induction air, or the air going into the engine, the more air we can get into it. It's simple thermodynamics. So in cooling down that charge, we increase the total mass flow into the engine, and then we can put more fuel in, and we can generate more power. Obviously, in the combustion chamber, sure, we get to some very, very high temperatures. You know, we'll see 2,500 degrees centigrade temperatures inside the cylinder after firing a spark plug. So that's part of the thermal loading that we have to handle going into the cooling systems in the vehicle.
So you talk about power. Tell us a little bit about the launch capabilities of this vehicle.
Yeah, that was another bit. We engineered a couple of technologies in there to enable us to launch the car very, very hard. So the car will pull about 1.8 G on a drag strip. For a 4,200 pound car, that's a pretty significant launch. And the way we do that, there are a couple of technologies we use. One is a transmission brake, where we actually lock the transmission in 2 gears at once. So when you're staging on the drag strip, the transmission brake holds the car instead of having to do it on the brakes. Then we can load the engine up, get some air going into the engine. And we also use a system we call torque reserve, which enables us to generate even more boost and get even more torque out of the engine when we let go of the transmission brake.
And you do it by just flipping the paddle?
Just flipping the paddles.
Boom. So like
off you go.
Anyone, you don't have to be hang on. But then something happens to keep it going straight too. Sorry, John.
No, keep going.
So you also have technology in place so that when you do release all that power, you know, you don't go like squirreling off into a side barrier.
Yep, and one of the things we obviously did was specifically configure the suspension on the car to load up on the back suspension. We want to get as much weight on the rear wheels as we possibly can to increase traction. And you've probably seen the videos of lifting the front wheels off the floor. So we're actually transferring 2,500 pounds off the front wheels onto the back wheels to launch the car as hard as we possibly can with the highest traction.
Which gave you, I guess, did you get a world record for a wheelie?
I believe it's the only certified by the Guinness Book of Records that will pull a wheelie as a standard production car, yes.
How far did you go?
I think it was 3 feet, 3 feet off the floor.
But it was for quite a distance as well.
I thought it was 2.92 feet. It's actually off the floor.
Okay.
So.
Still, just to be able to pull the wheels off the ground is saying something. But go back to this transmission brake. Mm-hmm. Why can you get more power locking the transmission than just locking the brakes?
With the brakes? Obviously, if you look at the skinny front tires we put on the car, there's no traction with those tyres if you're on the brakes. So they actually make the condition worse than the standard tyres. Doing it with the transmission brake, it's physically locked against itself, so we can generate a lot more boost through the engine and get that traction to the ground.
Okay, you brought up the skinny tires. You tell the story on why you get these with the car.
Yeah, the Demon Crate was an idea that the Dodge brand guys came up with. We wanted to give the purchaser the ability to drive the car to the track, fully road legal car, but then give it the best chance it possibly could to be to perform on the track. So obviously the lighter front wheels give us a benefit. There's less rolling resistance, and that comes in the Demon Crate.
So, talking about the transmission, this has a torque flight automatic transmission. Now,
correct. Don't
drag racers use manuals?
Some drag racers use manuals, some use automatics. The shift times that we get in the auto is actually make the car much faster than the manual. You cannot change gear manually as quickly as we can with an automatic transmission these days.
Well, and a lot of automakers use that argument, but that doesn't mean that people still don't want to try and do that themselves, even if they know it won't go as fast. Are you expecting, or have you already started to hear from customers who are saying, will you give us a manual?
We don't know of a manual transmission that can handle the power and torque. The one that we have in the standard Hellcat is not capable of handling a Demon power and torque, so we don't have an option.
It's at its limit with the current Hellcats.
Absolutely.
Well, I got to ask you the most basic question everybody asks anything about any car. How much does it cost? How fast will it go?
Well, the pricing's not been announced yet. How fast does it go? 9.65 quarter mile at 140 miles an hour, so pretty quick. The revised gear ratios that we have in the Demon, from a top speed perspective, it's slower than the Hellcat, about 20 miles an hour down, but really it's not made for outright top speed. It's made to go down the quarter mile as fast as it possibly can.
Was that the target that you set out in the quarter mile time? Did you hit your target?
We beat the target. The targets we had both for engine power and torque and the quarter mile time, the team managed to beat all of those. So,
what was the quarter mile target?
We had a 10-second quarter mile target.
So you beat it by half a second? Yeah. That's huge.
And we had a 777 horsepower target for the power out.
And you blew through that too.
How about the 0 to 60? What was your target?
We didn't have a specific 0 to 60 target. Obviously the car does 2.3 seconds, 0 to 60, measured in an engineering way there is no rollout included. So some of the typical magazines you'll look at test slightly different, and you'll probably see about a 2.1 second 0 to 60 with rollout.
But that's on a...
It's on a prep drag strip, yes.
Yeah.
Absolutely.
Yeah. Have you tried on a non-prep?
I haven't personally.
So you don't know if you beat the Tesla S or not?
Don't know.
What was the biggest technical challenge you had to overcome in hitting these targets that you set out for yourselves?
I think, as I said before, it's not a single one. It's meeting the emissions, the durability. We've got a 150,000 mile emissions. So it's really a lot of overlapping requirements that you have to fit together and then basically get something in the box that all of those requirements can be met. Obviously, some of the more typical requirements we have for a normal road car go away, so you don't have to worry about those on this type of product.
Mm-hmm. You mentioned that this is a supercharged car. A lot of people are hearing more and more about turbocharged cars.
Sure.
So why a supercharger rather than turbocharger? What is the difference here?
That decision was done a number of years ago when we brought Hellcat to the market. We did actually look at supercharged and turbocharged variants of the Hemi, but we really thought the supercharger brings back a lot of the DNA that everybody's looking for in a muscle car. Instantaneous throttle response, some of the noise elements that come with a supercharger, which are normally in a turbocharged car quite muted. So we believe for the product we were trying to generate, the supercharger was the right road. It is true that superchargers are probably not the most fuel efficient way of generating extra power. If we can use a turbocharger, then we can harness exhaust energy, which would normally be lost, versus mechanically driving a supercharger. But we were going for a very, very specific type of car and a very specific type of owner. And we think we got the DNA about right. You know, we've sold about 30,000 Hellcats now, which is about twice as many as we ever believed we were going to sell. Obviously, that success with Hellcat leads into Demon. Demon would never have happened if Hellcat hadn't been such a success. So I think generally we're pretty pleased we got the technology right for that specific buyer.
And you're going to make 3,300 of them? Is that
3,300. There's 3,000 coming to North America and 300 going to Canada. So.
And if demand proves to be as high as it was for the Hellcat?
No,
You're going to limit it, that's it.
3,300, it's an absolute limited edition car. Tim Kaniskis, I think, has made the commitment that that's what we're doing for Demon. Does it mean there can't be other special edition vehicles going down the road? Maybe. But no, there are only 3,300 Demons.
And have you started taking orders yet?
We have not started officially taking orders, no. I believe some of the dealers may be making promises. I don't think there's any dealer allocation made yet. Nobody knows how many they're getting, what they're getting. But I know there's a lot of customers out there very keen to get their hands on one of the few.
So when does that start?
Plan for production is cars will start to see the dealers somewhere August, September timeframe for an 18 model year.
This car runs on 100 octane fuel. Where does one get that?
It'll actually run on both fuels. It runs on premium 91 or 100. There are two brands of commercially available and street legal 100 octane fuel. So 100 octane is the highest octane fuel we can find that's street legal, been certified for use on the street in California. That's the reason we picked that fuel. Even with the running in the high octane calibration that comes in the aftermarket controller, we plan to have full emission certification with that 100 octane fuel. So basically that was why we picked the 100 octane.
And if you run at 91, what are the consequences?
If you press the button to select high octane and you're only running 91 in the car, the knock detection system in the vehicle in the engine will detect that fuel is not sufficient octane and automatically bump you back to the calibration, which gives you only 808 horsepower and 717 pounds-feet of torque. So, yeah.
Are there other things too that when you switch to the higher octane, do you not have a drag race mode that gives you other features as well?
There are some other drag race modes in the car, but you can run those on either fuel.
Chris, I find it fascinating. Here you are from England, designing, developing, engineering the most quintessential American drag car. How did this come all about?
It's an interesting story, actually. 20 years ago, I couldn't understand why the US automotive industry, and particularly the US powertrain industry, was going in a vastly different direction to the European. And so I said that I wanted to come to the States, try and immerse myself in exactly why those differences were there. Plan was to be here for 3 years. That was in 1996. So, I think there's a huge amount of work going on in the powertrain industry in North America. The internal combustion engine obviously is of great interest to me. If you look at some of the advances that have been made, some of these power outputs that we're generating are just unbelievable compared to years ago, 10 years ago, 20 years ago, 30 years ago. So yeah, it was an interesting trip, but clearly unusual for an Englishman.
So talk about the development of this engine. I mean, it isn't just like a brute force engine. You guys had to do a lot of sophisticated analysis in order to come up with this?
There's a lot of, we use all the same tools for a high performance engine like this versus a 40 mile per gallon vehicle engine as well. All the same simulation tools, right down to fundamental combustion simulation, where we can mix air and fuel within a computer, understand exactly how it's going to burn, understand exactly where the fuel's going to in the cylinder, and ultimately predict how much power we're going to produce or torque we're going to produce, and even emissions. We can get down to simulating emissions. So it's no different from a process perspective. We apply exactly the same thoughts, and that's one of the really cool things about the role I have with advanced engineering and SRT as well, because SRT gives an ideal opportunity to use some of the things that you're not always 100% sure about. You don't really want to put into a vehicle that you're doing 1 million a year until you've found out exactly what's going to happen. So the link between advanced and SRT is a really, really powerful one. And the chiller was a perfect example of, and similarly on the original Hellcat, the whole low temperature cooling loop, splitting the engine cooling loop to have a high temp one that cools the physical engine, and then a low temp one that cools the charge. That also came from the advanced group, and we see it on Hellcat, we see it on Demon, and you're going to see that system on a number of our future high efficiency vehicles as well. So it's a great example of how things move from the advanced space into low volume production and then on into mainstream production.
When you, sorry, go ahead, Elisa.
I was just saying, now, are you worried at all that there'll be, because there's only 3,300 of them, that there'll be price gouging, that you have to try and cajole the dealers into?
Of course, we can't control what the dealers price the vehicle at, unfortunately. I hope it doesn't happen. I hope the cars all go to enthusiasts and they pay reasonable amount of money for them, but you know, it's something that's unfortunately out of control. I know Tim Kaniskis is trying to come up with ways where he can at least influence that to not become a big issue. But we'll have to wait and see what happens.
And do you think very many people will actually drive it on the street, or do you think most people are going to trailer this thing to a track?
I think they're going to I think they will drive it to the track. I mean, the great thing is we've had Mopar drag cars in the past, even faster cars than the Demon, but they weren't street legal. There's no warranty. The emissions wasn't certified, and you had to have a trailer to take the thing to the track. This allows the guy that it's to drive the car, obviously not in the winter, in the summer, and then drive it to the track, race it, and take it home. I mean, I think, of course, there'll be some people that take them as collector cars, put them in the garage, and you won't see them again. But I think there's a bunch of enthusiasts that are actually going to drive them.
And do you think also that all of this attention that Demon has garnered, I understand this is having a positive impact on just sales of, you know, Scat Packs and helping Dodge in general?
I was talking to the Dodge guys the other day, and I think they'd had their best month ever for Challenger sales, obviously. And the same thing happened with when we launched Hellcat. Even when we announced it, but we hadn't sold a single Hellcat, there were a lot of people wanted to be associated with that type of product. Demon does it again. And you've got to remember that we have to pay for projects like this. I mean, they're expensive. If you leave, you know, only doing 3,300 cars, we've got to make some money out of the whole enterprise somehow. So that's all baked into being able to get something like this approved.
Chris, when you guys announced the car, there was all this internet buzz that the NHRA had banned the car. Mm-hmm. Can you, I know you guys say that's not so. Could you clear that up for everyone, though?
Yeah, it's in my understanding, there are 2 rules relating to the NHRA and drag racing vehicles. Any vehicle that goes below 10 seconds ET, quarter of a mile, is required to have a safety cage. Any vehicle that does higher than 150 miles an hour terminal speed is required to have a parachute. So it's not really that the vehicle's banned, it just sets a requirement for you to be able to race at that particular track.
How do you get around that if you're an owner and you want to race this? You got to put in a cage?
Put a cage in.
Okay.
Yep.
So Chris, you also worked on the Pentastar.
We did.
Which was more fun?
Many, many years ago, I only wanted to work on racing engines. My future was going to be Formula One engine designer, and I went and worked on a production engine program, and it totally changed my perspective of what I wanted to do. The programs have different challenges, but ultimately they are just as difficult. Pentastar, you're right, I started at FCA as chief engineer on Pentastar. We were planning to do 900,000 engines a year of that particular product. We're up to about 1.5 million now, and we've sold something like 6 million of the things. There is a huge amount of pressure, obviously, involved in 2 brand new plants, a brand new clean sheet of paper design, never seen the light of day before, and you've got to make it work, and you've got to make it work straight off. Demon is different. Yes, we push the numbers, we make the numbers crazy. You know, the idea is to basically post numbers that have never been done before, but from an engineering perspective, they're similar challenges. I said about the tools, they use similar tools and you use a similar sort of mind frame to do it. So I like the variety. I like doing, I like doing a variation. I've worked on weed whacker engines to super tanker engines in my past. So anything from a small rotary right up to something that powers a super tanker across the ocean. And the challenges are different, the goals are different, but the process and the thinking is sort of similar.
Well, now we know why they went to you to develop this Demon. With this, we're going to have to wrap it up. But Chris Collin, thanks so much for coming on today's show and talking all about Demon. I know we could go on for hours. There's a lot more detail. I wish we could have gotten into it all, but we got into some.
Thanks for having me.
Elisa, Gary, I want to thank the both of you for being here today. And of course, as always, I want to thank you for having tuned in.
In the auto industry, you need a partner that can develop the next game-changing technology and mass-produce it quickly. Borg-Warner can. Our expertise drives future mobility trends with fast-to-market solutions for clean, efficient propulsion systems. We understand the challenges you face. We know what you need to get ahead. We take innovation from the drawing board to the road quickly, providing localized production around the world. Borg-Warner, your partner in propulsion system solutions for a cleaner, more energy-efficient world.